In this playlist, we shall cover all the syllabus of matrix algebra prescribed by the university. So please subscribe the channel and don't forget to press bell icon so that you can get updates of this playlist. First, we shall start from system of linear equations. A linear equation in the variables x1, x2, x3, xn is an equation that can be written in the form a1 x1 plus a2 x2 plus so on an xn equal to b, where b and the coefficients a1, a2, a3, an are real or complex numbers, which are usually known in advance. That means the equation is called as a linear equation if powers of the terms containing the variable is 1. The equation is said to be linear if powers of the term containing variable is 1. See, in this equation, first term is a1 x1. Here power of this term is 1. a2 x2 power of this term is also 1, and similar for all cases. That means the equation in which power of the term containing the variable is 1 is called as linear equation. The subscript n may be any positive integer. In the term an(xn), the subscript n is a positive integer. The equations 4x1 minus 5x2 plus 2 equal to x1 and x2 equal to 2 into 6 minus x1 plus x3 are both linear equations because they can be arranged algebraically as shown in equation 1, that is 3x1, 4x1 minus x1, 3x1 minus 5x2 equal to minus 2. See here, power of first term 3x1 is 1, power of second term 5x2 is 1, and second equation can be written as 2x1 plus x2 minus x3 equal to 12. Here also the three terms are containing variables x1, x2, x3, and power of all the three terms is 1. That's why these two equations are linear equations. How to check whether the equation is linear or not? It can be checked by checking the powers of every term containing the variable. If powers of every term containing the variable is 1, then we can say that the equation is linear. The equation 3x1 minus 5x2 equal to x1 into x2 is not linear. Why? Because there is a term x1 x2 whose power is 2. Power of x1 is 1, power of x2 is 1, and we shall add the powers in the product term. Therefore, power of x1 x2 this term is 2, and hence it is a not linear equation. The equation x2 equal to 2 root of x1 minus 6 is not linear because there is a term root of x1, and root of x1 can be written as x raised to half, and that's why power of x, that term 2 root x1 is 1 by 2, which is not 1. That's why it is also not linear equation. Now, a system of linear equations, it is also called as linear system, is collection of one or more linear equations involving the same variable, say x1, x2, x3, xn. The system, the collection of more linear equations containing same variable is called as system of linear equations. An example is 2x1 minus x2 plus 1.5x3 equal to 8, x1 minus 4x3 equal to minus 7. These both equation contains same variables x1, x2 and x3. In second equation, x2 term is absent, but we can write it as a 0x2. Second equation can be written as x1 plus 0x2 minus 4x3 equal to minus 7. That's why both the equation contains same variable and both equations are linear equations. Hence, we can call this is as a system of linear equations or linear system. Now, we shall define some terms. A solution. What is the solution of the system? Solution of the system is a list S1, S2, S3, Sn of numbers that makes such an equation a true statement when the values of S1, S2, S3, Sn are substituted for the x1, x2, x3, xn respectively. That means if a system in when n variables is a given, if a system in n variables is a given, then the list S1, S2, S3, Sn of numbers is called as the solution of that system if every equation satisfies by this list of numbers when S1 is placed in place of x1, S2 is placed in place of x2, S3 is placed in place of x3 and Sn is placed in place of xn. The set of all possible solutions is called as solution set of the linear system. Second definition is solution set. Solution set is nothing but the subset of all possible solutions of that system. System may have more than one solution, then, and if system has a unique solution, then the set is singleton set. If the system has more than one solution, then we shall get a set, and that is nothing but the solution set. Two linear systems are called equivalent. Equivalent system we shall define now. Two linear systems are called as equivalent if they have same solution set. What is the meaning of this? That is, each solution of the first system is also solution of second system, and each solution of second system is also solution of first system. Then we can say that the two systems are equivalent. Finding the solution set of the system of two linear equations in two variable is easy because it amounts to finding the intersection of two lines. Finding the solution of the system of two linear equations means find the point of intersection of two lines because linear equation in two variables represent a straight line. Every linear equation of two variables represents a line. Thus, if we have a system of two linear equations in two variables, then we get two lines. And if we find the intersection of these two lines, that is the solution of the system. For example, we shall see these equations. X1 minus 2x2 equal to minus 1 and minus x1 plus 3x2 equal to 3. If you draw the graphs of this equation, they will be like this. X1 minus 2x2 minus 1, this is a one line L1, and x minus x1 plus 3x2 plus equal to 3, this is a second line L2. Clearly see that these two lines intersect at a point. These two lines intersect at a point. It is nothing but 3, 2. The point 3, 2. Coordinates of the point of intersection are 3, 2. Hence, the graphs of these two lines are which we denote by L1 and L2. The pair of numbers x1, x2 satisfies both equations. In the system, if and only if the point x1, x2 lies on both the lines. In this system, we can observe that the point 3, 2 is the only point which satisfies both the equations, both the lines. And hence, 3, 2 is nothing but the solution of this system of equations. Of course, two lines need not intersect in a single point. We know it very well because some of the lines are parallel, some of the lines are coinciding. That's why they may not intersect at a single point. If lines are parallel, they will not intersect anywhere, and if lines are coinciding lines, then they intersect at every point on the line. For example, x1 minus 2x2 equal to minus 1 and minus x1 plus 2x2 equal to minus 1. If you draw this graph of these lines, we will get these lines. these lines are parallel and hence they never intersect each other and hence it has a no solution. Third set, x1 minus 2x2 equal to minus 1 and minus x1 plus 2x2 equal to plus 1. If you draw these two lines, graph of these two lines, it will be this. L1 and L2 both are coinciding lines. Coinciding lines. That means every point on L1 is also point on L2 and every point of L2 is also point of L1. That means it has infinitely many solutions. This graph has infinitely many solutions. Friends, how to find the solution of the system of linear equations in two variables? If system of linear equations in two variables contains two equations, then draw the graphs of both the lines. They are straight lines. And find the point of intersection of these two lines. If these two lines intersect at a single point, then the system has unique solution. Then the system has unique solution. If these two graphs doesn't intersect, that means they are parallel to each other, these two lines are parallel to each other, then there is no solution for that system. Then we can write system has no solution. And if both lines are coincide each other, then we can say that that system of equations has infinitely many solutions. From this, we can conclude that a system of linear equations has either no solution or exactly one solution or infinitely many solutions. Now, when we shall say the system is consistent or inconsistent, a system of linear equations is said to be consistent if it has either one solution or infinitely many solutions. If the system has one or more than one solutions, then we shall call that system as consistent system. And if the system has no solution, then it can be called as inconsistent system. We shall solve this system by matrix method also. For that, what is a matrix notation? The essential information of the linear system can be recorded compactly in a rectangular array called a matrix. Called the matrix. We shall write the coefficients of equations in matrix form. For given this system, x1 minus 2x2 plus x3 equal to 0, 2x2 minus 8x3 equal to 8, 5x1 minus 5x3 equal to 10. For this system of equation, we shall write the coefficient of each variable aligned in a column. That is coefficient of x1. In first equation, coefficient of x1 is 1. In second equation, x1 term is absent, therefore 0x1. In third equation, coefficient of x1 is 5. Therefore, the matrix contains first column as 105 because 105 are coefficients of x1, first variable. First column is for first variable. Then second column for second variable x2. In first equation, coefficient of x2 is minus 2. In second equation, coefficient of x2 is 2. And in third equation, coefficient of x2 is 0 because x2 term is absent in third equation. Therefore, in the matrix, second column is minus 2 to 0. And third column is a coefficient of third variable x3. In first equation, coefficient of x3 is 1. In second equation, coefficient of x3 is minus 8. And in third equation, coefficient of x3 is minus 5. That's why the third column of the matrix is 1 minus 8 minus 5. Thus, we can construct matrix of coefficients of the system of the equations in the system. And this matrix is called as coefficient matrix, or it is also called as matrix of coefficient. How we can write the matrix of coefficient or coefficient matrix of the system of equations? It can be written by writing the coefficient of first variable in first column, coefficient of second variable in second column, coefficient of third variable in third column, and so on. Further, augmented matrix. We have this matrix for that system. One first column is 105, second minus 222, minus 220, and third column 1 minus 8 minus 5. And we have seen that the constant terms to the right hand side of the equation are 0, 8, 10. 0, 8, 10 respectively are the constant to the right hand side of the equation. Therefore, what we shall do? We shall write the constant terms as a next column in this matrix, in this coefficient matrix, that is 0, 8, 10. This is the fourth column. System of equation contains three variables, therefore first three columns are coefficients of three variables, and fourth column is constant term to the right hand side of the equation. This is called as augmented matrix of the system. The second row, which contains a 0, because the second equation could be written as 0x1 plus 2x2 plus minus 8x3 equal to 8, like this. An augmented matrix of the system consists of the coefficient matrix with an added column containing the constant from the right side of the equations. The size of the matrix tells us how many rows and columns it has. The augmented matrix has 3 rows and 4 columns. The horizontal lines are called as rows. In a matrix, horizontal lines are called as rows and vertical are called as columns. In this matrix, there are 3 horizontal lines and 4 vertical lines. So this matrix contains 3 rows and 4 columns, and it is called as 3 by 4 matrix. 3 by 4 and can be written as 3 multiplication sign and 4. If m and n are positive integers, an m by n matrix is a rectangular array of numbers with m rows and n columns. While writing the order of the matrix, write number of rows first only. Don't write number of columns first. Number of rows are first. If a matrix contains m rows and n columns, then order can be written as m by n. Dear friends, we shall see how the system of equations containing more variables can be solved by using matrix method in our next video. If you have not subscribed the channel, please subscribe it, as we are adding more videos on matrix algebra. Press bell icon to get updates of this channel. Thank you. See you in next video.